So I mentioned in some previous videos soil testing for iron and zinc. And when you send a sample, a soil sample specifically, into a soil testing lab for them to determine plant available or available iron or zinc, they use an extractant. All right, so they don't do a digestion. They don't determine total iron or zinc in a soil. They actually use an extractant or a solution that extracts a small portion of iron and or zinc, and then they quantify those concentrations and come back to you with a recommendation. So how does this actually perform? I need to give you some background. So most of the micronutrients that we're discussing, including iron and zinc, are found in the soil as either precipitated inorganic compounds, mineral phases, or are organic or organically complex. There are organic matter complexes that are present. I can tell you that a very small amount of iron and zinc and other micronutrients are found on exchange sites as well as in the soil solution. So what does a laboratory do to mimic what a plant might see? The soil tests that are used in laboratories use oftentimes a chelate and sometimes some weak acids to extract iron and zinc and other micronutrients. And we use these extractants that contain oftentimes a chelate to capture or grab a hold of, or I guess chelate, claw-like or crab-like is what it means, to capture and hold on to these micronutrients and keep them in solution so we as scientists or laboratory managers can analyze those elements. So this is the general scheme, that we use either a chelating solution to extract iron or zinc, or we use a chelating solution with some weak acids to dissolve some of the compounds that contain iron and zinc, and put iron and zinc in the solution, and then use a chelate to keep iron and zinc in solution so we can quantify them. So let me talk about the types of chelate lab extractions that are used across the US. So the first one I want to talk about, because it's widely used, is DTPA. And often labs will use this extracting solution. It's 0.005 molar DTPA. And it stands for diethylene triamine pentacetic acid. You don't need to remember that. It's DTPA. This solution is buffered at a pH that causes some soil mineral phases to dissolve slightly, and those, by doing so, that pushes the metal ions into solution. And then the chelate grabs those metals and keeps them in solution so we can measure their concentrations. If we didn't dissolve a portion, a very small portion of the mineral phases, and we didn't have something in the solution to prevent those metals from reprecipitating as mineral phases, they would reprecipitate as mineral phases. So the DTPA, the DTPA is added to chelate those metals so we can measure them. In Ohio, we follow a very similar protocol. And in Ohio, what people are utilizing is the MELIC-3 extracting solution instead of DTPA. The MELIC-3 extracting solution contains EDTA, which chelates and complexes the metals. And it's not written on this slide, but the MELIC-3 extracting solution actually contains some weak acids. I'm sorry, contains low concentrations of acids. They're not weak acids. There are very low concentrations of acids: hydrochloric acid, acetic acid, nitric acid. And those three acids help dissolve a little bit of the metal mineral phases that are present. And the chelate is there to capture the metal and keep it in solution so we can measure it.